to introduce my group, which is Group 1, Blue Box Electric Pressure Cooker. My name is Pankaj Singh, and I was in charge in dealing with the Verilog coding.
Hey guys, my name is Kukul, and I'm from Group 1, Blue Box, which is stand for Electrical Pressure Cooker. And today I will manage about the state diagram.
My name is Amir Rizwan. I'm doing the report for electric pressure cooker. Thank you very much.
Hello, my name is Ros Anis Farhan. Today I will present about introduction, objective and conclusion. And I will present introduction first. Okay. What is pressure cooking? Cooks foods using steam pressure. How does it work? For the first one is raise the water in the pot to boiling point, and second one is raise the pressure, forcing the steam into the pot. Okay, like this. Okay. How does the electric pressure cooker looks like? This is consists of three parts. At the top it is the lid, at the middle in the pot, and at the bottom housing unit. Stop. What we learned at our project. Okay, first, we to study and understand the operation of electric pressure cooker through its state machine. And second is to identify the inputs, outputs, and state of the electric pressure cooker. And the third one is to construct the Verilog coding and simulation based on the operation.
For electric pressure cooker, we have found that there is 4 stages, which is the first stage is stand for idle, which means the starting process, and the next is we have a selection. The 2 and 3 is stand for selection, whether you're going to choose rice or porridge, and then the 4th is you will go for cooking. It's just a simple, but we will bring out for we will do with a 2 input, and then we also have a 2 output. So for the input is each step there will be 4 different possibilities due to the input being a 2-bit. So for inputs, the reason why we choose the 2 input is they can be a 4 input. The maximum is 4 input. Later at the state diagram I will explain. For the 2-bit output is we have 2-bit, which is bit 0 stand for locking the mechanism, which is locking the lid of the electric pressure cooker, and then the bit 1 stand for cooking. So now let me explain to you. The state diagram is start from here, where is the start, and the output is stated in here. And for our state diagram, we are using a more more slope. So for start, let's say we are choosing a 2-bit. Let's say if the input is 0, 1, it will go for rice selection for the it will go for state 1. And if you are choosing 1, 0, it will go for porridge. And the 0, 0 and 1, 1, it will be loop itself, the state. So when you go for the rice, we can see here the output is 0, 1, which means you lock the lid first. 0, 1 stand for lock. It will turn on the lock. At the rice here, we can see there's a 4 input here. One is if you accidentally press the button for rice, if you want to change it to porridge, what we can do, you can simply press the input, key in input 1, 0, it will switch to porridge. Or if you press 0, 1, it will loop itself, where it will select the rice. And another setting is another input, 0, 0 stand for, it will go for restart. Let's say you accidentally press the button rice, or actually if you don't want to cook, but you accidentally press the button, you just press 0, 0 to go for start, where it will be idle. And if you select the rice, if you want to cook it, press the input 1, 1, it will go for cooking. And the same process goes for state 2, which is porridge. If you press 1, 0, it will go for here, and the output is 0, 1, which is it will lock the lid first. So if 1, 0 means it will loop itself, and 0, 0, if you press key in 0, 0, it will go for start, reset. If you want to switch from porridge mode to the rice mode, just key in 0, 1. You can see the arrow here, it will switch to the rice. And If you're okay with the porridge, if you want to cook it, just key in 1 1, it will go for cooking. And the output here, you can see is 1 1, which is stand for it will lock, at the same time it will cook, it will start cooking. So the process ends here. So after the cooking, what will happen is it will reset it back, go back to the initial state, which is start. So that's it. So the input for after the cooking state is 0001 1011. Whatever it is, it will go, just go back to the start, which means the reset. So that's it. That's it for me. Thank you.
So I'll be explaining about the Verilog coding. So at the beginning, we need to declare our inputs and outputs based on what we just did for the state diagram. So from line 22 until 31, you can see that we already declared the inputs and the outputs. The inputs are clock, reset, and in the clock and reset is there due to the flip-flop that we're using, which is D flip-flop. And then we got output as well, which is the out and state. State is to be used only for the internal programming, which is the 4 steps that we just learned just now, S0 until S3, which are, since there are 4 states, we need to use 2-bit. Okay, next, we need to assign our states, the 4 states that we just learned just now, the either, rice, porridge, and also cook. We declare that as 2 bits. So after that, we need to set for the. Now that we have our Verilog code and also the text fiction done, if we did nothing wrong for both of the coding, it should come out simulation like this. So at the beginning of the 14 nanoseconds, we see that it's, the input is don't care and the output is also don't care. This is because our reset is turned on. That's why that it doesn't detect the input and the output, because when reset is on, it will negate any of the value given by input. So next up is the what we just declared at the starting, which is to test whether or not it will continuously loop itself if the input we give is 0, 0 and 1, 1. So as you can see, the first input, which is 0, 0, it leads to the state remaining at 0, 0, which means that our output is also 0, 0. Same goes for the 1, 1 as well. So next up, we need to test whether or not the cooking is gonna cook rice and then reset itself. So the third input, which is 0, 1, it shows that the state has now moved to 0, 1 as well, which is the rice state that we declared. And we can also see that the output is now 0, 1, which means that the locking mechanism has turned on, and that's why the output turns to 0, 1. So after that, we go into the cooking state, which is to the input bit 1, 1. Which also shows that our state is now 1, 1, which is the 4th stage, which also means it's cooking, and our output is 1, 1 as well, which means that the locking mechanism is on and the cooking has started to begin already. So as the starting of the first 5 bits that I just showed, it means that we can assume that our simulation is correct and it's doing exactly as what we did for the state diagram.
About the truth table. Actually, the truth table is for, we know the input, next stage, and the output. Okay. Therefore, the final state have a 4 state: SO, S1, S2, and S3. Okay. For the input SO, we have a 4 possibility input: 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. For each state, they have a 4 possibility input. And the current is for S0, they have a 0, 0. For S1 is 0, 1. For S2 1, 0, and S3 is 1, 1. For the next stage is actually the next stage when what will happen is when we actually okay, next is a K-map. K-map actually is for simplify the truth table, which is we know the output for the logic gate. Next. For the A star, we know the output is X, Y bar, A bar, and X A bar, because the following way with number ones, when the input have a 1 number, then can create the simplify of the output for A. And B also following, which is have a 1 input, they have can produce the variable output. And following the ZO and Z1, when the output have a 1, they have the variable is state, and Z1 also the following, which is if the output have 1, they have their own variable output.
Looking at the K-map, what we get is the expression for A, B, and ZO and Z1. So, using the expression, we can know that using the logic gate, we have designed the logic gate to give an expression where A is equal to something. So, and this logic gate also give expression that is equal to B, and those input will enter to D flip flop, will enter the D, and what we need now is we need a Q0 and Q1. So using the Q0 and Q1, we can find Z0 and Z1. To find the Z0, what we need to use the hand expression for Q1, Q0, and then for Z1 we just have to do an OR gate for Q0 and Q1. So by doing this, we can get the output Z0 and Z1.
For conclusion, our project is at the end we understand how the operation of pressure cooker truck finite state machine. Those who didn't know how to construct the Verilog coding, now they know how to do this. At the end, overall is we already learned how to simplify our electric pressure cooker into Verilog. But we have remember that by an electric pressure cooker, if you are and have more person who love the combination and doesn't mind the extra time it takes for an electric pressure cooker to